Okay, background reading about particles and what happens when matter is heated. Matter, solid, liquid, gas on Earth, matter is either found as a solid, liquid, or gas. A particular solid, liquid, or gas might be made up of individual atoms or molecules. Here is a simplified model of three different substances. One is a solid, another is a liquid, and the other is a gas. In the picture, the little motion lines show that the particles or atoms or molecules that make up the solid, liquid, and gas are moving. In later chapters, the models of atoms and molecules will be shown with much more detail. As you look at these pictures, think about these two big ideas, which are always true when talking about matter. Matter, whether it's a solid, liquid, or gas, is made up of tiny particles called atoms and molecules. The atoms or molecules that make up matter are always in motion. These first two ideas make up a very important theory called the kinetic molecular theory of matter or kinetic particle theory of matter. Another big idea is that the atoms or molecules that make up a solid, liquid, or gas are attracted to one another. So remember, we talked about this. Kinetic energy tends to pull particles away from each other. Attraction between the molecules, or IMAs, or intermolecular attractions, tend to pull the molecules together. So in a solid, the atoms are very attracted to each other. Strong IMAs, the molecules are very close. Because of this strong attraction, the atoms are held tightly together. The attractions are strong enough that the atoms can only vibrate where they are. They cannot move past one another. This is why a solid keeps its shape. Okay? In a liquid, notice a little bit more disorderly, and the person who drew the picture drew larger motion lines. Okay. In a liquid, the molecules are also in motion. The attractions between the molecules and liquids are strong enough to keep the molecules close to each other, but not in as fixed or orderly position as if you see in the solids. Although the molecules stay very near one another, the attractions allow the molecules of a liquid to move past one another. This is why a liquid can easily change its shape and flow, kind of like if you had a handful of marbles and you moved your hand and your fingers and allowed those marbles to slide across one another. Okay? In a gas, and what I don't like about this diagram is I feel like they should show a third motion line to show that gas particles have more kinetic energy, or draw the lines even bigger. Okay, but in a gas, the molecules are also moving. The attractions between the molecules of a gas are too weak and almost non-existent to bring the molecules together. This is why gas molecules barely interact with one another and are very far apart compared to the molecules of liquids and solids. A gas will spread out evenly to fill any container. When looking at the different states of matter, it's kind of like a competition between the attractions the molecules have for each other compared to their motion of the molecules. The attractions tend to keep the atoms or molecules together, while the kinetic energy or motion tends to make the atoms or molecules come apart. And then this chart, if you read over it, it talks about the intermolecular attractions of the particles in solids, liquids, and gases, the kinetic energy, and also whether these states of matter have a definite shape and or volume. Okay, heating and cooling liquids, which will be helpful to you if you understand this information before you try to complete your Ivory Soap activity. Heating and cooling a liquid, and the same thing is true for gases and solids. This is just an example, but heating and cooling a liquid can affect how far apart or close together molecules are. So this is showing you cold water, the motion and the spacing between the molecules, room temperature. Notice a little farther apart, a little bit more motion, and hot water a little farther apart. So it's showing an expansion and even more motion molecules. So one example is the red alcohol inside the thin tube of a thermometer. When the thermometer is heated, the molecules of alcohol move faster. The faster motion competes with the attraction between the molecules, which causes them to spread out a little. They have nowhere else to go in enclosed space like a thermometer in that glass tube, so the molecules move up the tube. When the thermometer is cooled, the molecules of alcohol slow down And the attractions between the molecules make them draw closer. This attraction between the molecules brings the alcohol down in the tube. So, again, it's just important to notice what happens as you're heating a solid, a liquid, or a gas, what happens to the distance between the molecules, and their kinetic energy.